We're going to look at the code requirements for refrigerant piping insulation, and specifically for the high pressure vapor side when used for heating. Those VRF manufacturers that have high pressure vapor operating temperatures above 200, which is 200 degrees Fahrenheit, is the demarcation between having to go from 1.5 to 2.5 inches in thickness for pipes under 1.5. So if their operating temperature is above that, you're going to have to put in 2.5 inches thick of insulation. I haven't seen an installation with this thickness, but it does fall under the building energy efficiency standards for high pressure vapor pipe above 200 degrees Fahrenheit. What we'll look at now is using the 2019 Building Energy Efficiency Standards in California, or the IECC is our example. You should review your model energy code or building codes for the requirements in your jurisdiction to see how they compare with this discussion. I have replicated the 2019 Building Energy Efficiency Standards Table 120.3-A pipe insulation thickness below for this review, which matches Table C403-11-3 of the IECC International Energy Conservation Code and ASHRAE 90.1, Table 6.8.3-1. Now, looking at the table, you can see that anything with a temperature, field operating temperature range between 141 and 200 degrees Fahrenheit will require 1.5 inches of insulation for pipes under 1.5 inches. And it'll require 2 inches of insulation for everything above 1.5. 1.5 and above will require 2 inches. Now the problem comes in if your VRF manufacturer on the high pressure vapor side is above 200, which some of the manufacturers' operating pressures are. So you need to confirm when you're choosing a VRF manufacturer what their operating temperature is for their high pressure vapor side. If it's above 200, then you're going to fall in this category of 201 to 250, and as you can see, everything under 4 inches of the 4-inch pipe size, all pipes under 4 inches require 2.5 inches of insulation. And anything 4 inches and above require 3 inches. So I haven't seen this done yet, but you need to be aware of the high pressure vapor temperature of the VRF manufacturer that you're choosing. Now let's look at some examples of poor installation methods, items that you should look to avoid when installing insulation on refrigerant piping. The first one here, attaching a pipe clamp directly onto the pipe, not a good idea. Your insulation should continue through, and you should use some form of insert like the one from Aerofix here. This one here shows how to use an insert properly. Of course, you're going to butt the insulation up to the insert. You're not going to have that gap there. That's just to show you the insert. Your insulation needs to go continuously, but this avoids crushing your insulation or having your clamp directly on the pipe, which would be a good conductor for losing heat and energy from your pipe. Now this one here, you can see brittle insulation, lacking UV protection and using plastic ties. It's not even attached to the unistrut. This one is, horrible. You can see it's just crumbling apart from the sun beating on it constantly. That's why the code requires UV protection, and often that can be accomplished with aluminum jacketing, or if it has some kind of UV protection on the insulation itself. Armacell has theirs coated, but they recommend that you coat their exterior insulation with 2 coats of WB finish and then recoat it every 2 to 4 years. That sounds like a lot of work, and you got to remember to do it. Otherwise, you're going to have degradation of your insulation. The best is to use aluminum jacket. Then you don't have to worry about recoating every 2 to 4 years, as recommended by Armacell. Next one here, obvious, right? Missing insulation. How many jobs have you walked where you see a piece missing? I don't know how this happens, but it's on plenty of job walks I've been on. So make sure your insulation's all the way through. Once again, they used some plastic ties. They're squeezing the insulation. Just really poorly done. And then once again, I can't see exactly what they got here, but it doesn't look like the proper insert because the insulation diameter is much greater than the whatever they're using in here inside the clamp. So they should match up so you can get a good butt joint from the insert to the pipe insulation. Once again, now this one here, just plain old missing pipe insert. There's nothing holding this pipe to the support. It's just sitting on it. And you got all this exposed copper. These joints need to be butted up to each other. So once again, a very poor installation. Split insulation, there's bad joints and seams. This one, the insulation has come apart. It's just a poor seam. And you can see over here that there's a mismatch between the outside diameter of this insulation and this insulation. So it's exposing the other portion of this insulation. So once again, you got to make sure all your seams are sealed. Another one, a poor joint insulation. You can even see that whatever tape they used just deteriorated. It's not even making a good joint.